All
right. So I invited Josh too, but I haven't seen him yet.
Okay.
He'll join when he comes. So for 1 and 2, true. Number 3. This one is in the reading. It's a little bit different than what it usually is, but it's basically the same. I came up with
the mean is normally distributed for each group, right?
Yeah. Both the top one and the second one. So a simple random sample was drawn from each population.
Yeah. Okay.
And the one you said.
Sweet.
Yeah.
Effort.
Number 4, t-statistic is the same thing as a t-score.
Right.
5, 2 samples are independent if it's the second one. Knowing which subjects will be in group 1 tells you nothing about which.
Right.
And then for the next 6 questions, basically, we're using this quantitative inference thing with this dentist office bills.
Right.
And plug it in on that 2 sample t-test that we were just talking about.
Mm-hmm.
So for number 6, for the degrees, I got 37.996.
Okay. And here, let me pull mine up real quick. I just want to make sure that I got the same stuff you do.
Yeah, totally. I'd like that too. That way I know I'm doing it right.
I thought I had my Excel already up, but let me.
Yeah, there's only one that so last test on Monday, I couldn't get the margin of error. That's the only one I'm having a problem with. I know the formula, but for some reason I'm not getting the right stuff. I don't know.
Huh. Let me. All right, I got that. Let me do dentist office bills. Come on. Oh, there we go. Oh, there you go. Oh. Yeah, I was doing the homework, and so I still have the numbers from the homework on this thing. So clear content, and then click that, and we paste. Okay. All right. So I have the DF is 37,996.
Yeah.
All right. Sample standard deviation for Rexburg. Which one was Rexburg? The first or the second?
The second one.
Second one, 206.637.
Yep.
All right. The T-score, negative 0.434.
Yeah, that's what I have.
P-value, 0.66. Looks like 0.667.
Yeah, that's what I have too. And then number 10, I did belt reject since it's crater.
Yeah. Suppose instead that you had an alternative hypothesis that you did not equal that.
So I did the first one on this one.
So you have sufficient evidence that dentist bills between the two cities are different.
Yeah, so if you look at the standard deviation, it's different.
Oh, right, okay.
And the p-value is higher than the alpha or whatever.
Right.
So that's why I said that one, but I'm not 100% on that.
Well, yeah, because, okay. Because we can change the not equal to, well, I guess that's, well, it's already set for not equal to, so.
Yeah.
So on your 2 sample tests, it's actually testing that anyway, so I guess, yeah, I guess so.
Oh, shoot. So,
do we have a different confidence level? That would be my only. No? Yeah, because we're supposed to be at 0.9. Ooh, good catch. It didn't change anything, though.
Yeah, so if we do the type of test be less than, because that's what it's asking for, and a couple of the numbers change, the p-value changed.
P-value still, oh, so 0.667 is what the p-value would be.
You have it at, what's your confidence level?
I changed the confidence level to 0.9.
Okay, that's what I have. And then your type of is less than?
I still not equal to, less than. Okay, so now we're 333.
Yeah, that's what I have.
Everything else should be the same still, though, right?
Yeah. Yep.
No, 206. Yeah, okay. Cool.
Awesome. Number 12. So the freshman thing.
All right, let me load those up. All right. So we're at 0.5, right? So that's a 9.95. Back to there. And that's equal to so with the middle one would be the alternate hypothesis, correct?
Yeah, where it's not equal to?
Yeah.
Yeah, that's what I have.
Okay. The t-score 0.845?
Yeah.
P-value 0.410, so 0.411?
Yeah, that's what I have. And then I failed to reject 6 greater.
Yep.
Number 16, I keep messing up on this one. I don't know how to do it.
Oh, the margin of error?
Yeah.
So determine a 95% confidence interval for U1 to U2, an estimate difference between. So that's your mean, or not your mean,
Yeah, that'd be your mean minus your mean.
Yeah, your mean 1 versus minus your mean 2. And then divide that by 2, right? I don't know. Or I don't know how you do that. So it'd be.
So the margin of error, the way they have it in a couple lessons ago, was 2 times the standard deviation divided by the sample number.
Right.
So,
but how would you do that with? Oh, I guess you have to do. You have your intervals U1 to U2, so your mean 1, mean 2, and then you do your standard deviation. You subtract the standard deviation on that also the same way and make it average?
Good question. I don't know. I mean, the standard error of the mean is just the right of it. Error of the mean, but that's not the margin of error. Shoot.
Here, I got. Well, at the bottom, I know it's not going to be in the top.
Like you said, with the standard deviation minus the other one, if I read the information of it here, it's saying determine the 95% confidence interval for U1 minus U2, which is estimate. That's the difference. Now you have to.
So here I got on question 22 on step 5, it says create a 90% confidence interval for the difference in the mean response of the two groups. So it says subtract the one from the other, and you get 158.5 and 24. So I'm assuming.
Is that on the?
Okay. It's on the textbook. So I guess you got to do the same with the standard deviation also, is what it looks like.
What number was that one?
Yeah, if you go all the way down to step 5, and it's number 22.
Number 22. And that's create a 90% confidence interval for the difference in the mean.
Yeah. Isn't that what we're doing?
Yeah. That, but it's the margin of
error. We're doing the margin of error.
Yeah.
Well, I didn't read that part.
That's the next part on the question.
So margin of error.
So standard deviation divided by square root of sample size times this z value or the t value. But the sample size is one that's 12 and one that's 10. Do you think the sample size would be?
What's that? I'm sorry.
For the sample size, since we're doing U1 minus U2, you think we'd take the sample size 12 minus 10? So it'd be a sample size of 2? What do we add them there?
What I'm looking at is margin of error tells you how many percentage points your results will differ from the real population value. For example, a 95% confidence interval with 4% margin error means that your statistics will be within 4 percentage points of the real population value. Margin of error can be calculated in 2 ways. Critical value times standard deviation, or critical value times standard error of the statistic. So is critical value would be that between the two, correct?
Yeah.
And then times standard deviation.
That's in lesson 10?
No, that's on Google.
Oh.
Sometimes it's a little bit easier.
Okay, so in lesson 10, this is what it says. The margin of error is half the width of the confidence interval. It is the distance between the point estimator and one of the bounds of the interval. If you have a large margin of error, your confidence interval will also be large. If you have a small margin of error, you will also have a small confidence interval.
Well, I mean, technically, then, so just the difference between, so your confidence interval, it's just going to be your standard deviation from one side to the other, right? So that would be your margin of error, basically.
Makes sense.
Right? That's all I'm just asking, because, I mean, your standard deviation is 1 degree, or 1.
But your standard deviation, your standard deviation is what you're saying. It's 1 up and 1 down.
Yeah. So like if you take variable 1, or I'm sorry, yeah, let's just say variable 1. That's 3.420, right? So our mean is 16.667. Our standard deviation would be 16.667 minus 3.420, and then plus 3.420.
Yeah.
So, and that would be, if we do the 68, 95, 97, or whatever, that rule. So that would be 2 standard deviations off, correct?
Yeah.
So your margin of error for a 95% confidence level would be the area that's inside the 95%, correct?
Yeah, that actually makes sense. So we'll do 2 standard deviations. And, okay, let me pull up that output real quick.
I mean, that's the way I understand it. I don't know if it's right or not, but that's, I mean, if we're playing the margin of error for a 95% confidence interval, that would be the area of 95%, which would be 2 standard deviations, correct?
Yeah. Yeah, you're right. So if I type in, let's see.
Our t-score, well, you'd have to have the z-score, correct?
Yeah.
Or actually, you could probably do it on the can you do it on the t-score?
That's what I have up right now. I typed in the t-score of 0.845. The thing is I can do an area, but I don't know what the 95% would be, because usually on the normal,
right? Yeah.
You type in the 95 on the top, and then you work backwards with your z-score.
Yeah. So how to get the 95 from there? That's just basically, I don't know.
Dang it, this one's dumb.
I know.
So we need one number to be able to get the margin of error, and it's saying U1 minus U2. So do you think we should do the mean of the U1 minus U2 and then the standard deviation of U1 minus U2? And then
Hold on, so find the margin of error from confidence level, find the sample size N. Okay, so you end up having to get the Z score to get it.
Okay.
So sample size N, multiply it by the same proportion, but divide the results by N, take the square root and calculate a value and multiply the results by the appropriate Z value for the confidence level desired. I don't know. I'm confusing myself, so.
Yeah, I don't like this one. How to take two sample and work it to one.
Oh, counting doesn't help me. Oh, okay. So I think we have to do, well, I don't know. So you got to go 2 up and 2 down off of the mean. Right?
Yeah.
And so, and that will give us our 95% confidence level, and then find the area off of that.
Yeah, but we have to have one standard deviation, not two.
No, well, I'm reading on that lesson 10, and it shows 95 will be 2 standard deviations of the population mean.
Okay.
Because one standard deviation will only be 68.
Yeah.
And then 2 will be 95, 3 would be 99.
So on the lesson 10 preparation, 5B, the z-score for 0.95, remember how they said the z-score would be 1.960?
Uh-huh.
So we can probably use that.
Maybe. I mean, we're probably making this way harder than we need to, but
yeah, I don't know.
What's going on, guys? When did you guys start?
4:30 or 5:30.
Oh, I was on at 5:30. I just didn't get any info.
Hey, we need your help.
All right, which one?
16, isn't it?
Yeah. Yeah, number 16 is the only one.
Did you already submit it?
No.
No, not yet.
Isn't that the one that we couldn't get last time and we were trying?
Probably.
The margin of error. So the formula, I was looking at mine, and last time I was saying 2 times the standard deviation over square root of sample size, but it's actually z times that.
Yeah, your z-score, right?
Yeah, so that's why I was doing it wrong last time, but I don't know how to do a margin of error with 2 samples.
Well, it's telling us the U1 minus U2. Or it could be, I mean, we have to do the average between the two. You know what I mean?
Yeah. Did you submit yours already, Josh?
I had one attempt, yeah.
Did you get that one wrong?
Yeah, I put 13.
You put what?
13.
13?
Yeah.
Your guess?
No, I think I must have had some reason why, but it said here as feedback, the answer is the average between the 2 results. I don't know.
And is that in the reading?
That?
Is that in the reading you said? The average is...
No, that's from my feedback.
Oh.
It says the answer in SPSS is slightly lower than in Excel, so the answer given is the average between the 2 results. The results should be close to the answer shown.
Alright, that's what Dennis just said too, so... the average of the 2 results.
Hold on, and I'll tell you. 31.867 divided by 2. 15.9335.
Alright, that's what I got too. So should we put that one in, round it to 3?
Round it to 4 or round it to 3?
To 3. So 15.934.
All right.
Is this your guys' first time?
Yeah.
Number 17, the lower bound would be negative 2.214. And then number 18, 5.147.
No. They're not right.
What's not right? The lower bounds?
The upper and the lower. I submitted mine and it wasn't right. I don't understand why they're different, but yeah, mine says the same thing his did. You know, the answer in SPSS is slightly lower than in Excel. So the answer given is the average between the 2 results. Your results should be close to the answer shown. I don't know what that means. But the last 3 were wrong.
Yeah.
And so is the T-score for 845.
That's number 13.
Yeah. And
number 11.
Yep.
So I saw somewhere in the reading where they kind of mixed them, like how they equaled each other out. So I think you could probably put negative 5.147 for the lower bound and 2.214 for the upper bound.
For 6, the degree of freedom is 20.
Number 6?
Yeah.
37.996.
Yeah.
That seems like an awfully weird number for a degree of freedom.
Yeah, I know, but that's what it averages between the two test groups.
Yeah, and it's right on our end.
Okay, okay.
What did you get for number 11, Josh? Did you get that one right?
Yeah, we have insufficient evidence that the mean dentist bills between the two cities are different.
Okay.
So B instead of A.
Yeah.
I think we did. I think we changed everything, and then we didn't change that one.
Oh, that makes sense. Yeah, number 13. Let's see.
So 845 is not it. But we got the p-value. Go figure.
Yeah, that's weird. And I thought we could get the F on this.
For number 8, how'd you guys get that test statistic?
Number 8?
Yeah.
So when you open up that Excel file, it's called quantitative inference procedure. You know which one I'm talking about?
Yeah.
So, and you go down to the third tab called two sample t-test.
Yeah.
You're supposed to put the dentist information in on the left-hand side of the Excel file. And once you have both those in, they'll give you the t-score labeled T in the table. And the answer for T comes out to be negative 0.434.
Okay.
Does that make sense?
Yeah. I was doing it individually. Okay.
Yes, I guess our big ones is number 13, 16. Yeah.
Would that make 9.667?
For which one?
9.
No, it'd be 0.333 because the
opposite.
yeah, the type to test is less than.
Oh yeah. All right. Okay, we'll see.
Josh, did you do number 13?
More? No. Or I did, but I didn't get it right.
Okay. Yeah.
Same numbers. Okay. So we're doing something wrong.
Yeah. So if you
Why is the test statistic off, though?
That's what I'm trying to find out. So if you do the confidence level and change that around, that wouldn't change the T statistic. And if you do the type of test and change it, it doesn't change it either. The only thing that would change it is the assumed equal variances, but that changes the p-value, which we got right.
Right. Could it be a negative 8.45 or 0.845? Because that's not going to change the. Well, it will still change the p-value though. Or no, that because that's still the same standard deviation. I don't know.
Let's see. So for a t-score is the same thing as getting a z-score, basically, right?
Yeah. Yeah.
Pretty sure.
Yeah, t equals x bar minus u. So your mean versus your. over S divided by square root.
Yeah. So maybe if we did a t-score for each one, added them together and divided by 2, maybe. But that'd be the average. I don't know if that'd work on this one.
Not equal to. This less than or greater than 2.
Okay, so it shows it down step 4, but the test statistic and its value. So let me see.
Ooh, so in the reading, it gives the example of a t equaling 1.455, and then right after it says if the group labels are switched, then the t statistic will have the opposite sign. So just like what you said earlier, Dennis, on the t-score.
Oh, yeah.
So I think that means it'd be a negative 0.845. But what do you know what it means if the group labels are switched? What does that mean?
So that means if variable 1 is actually on variable 2 and variable 2 is on variable 1.
Okay.
So that just means the information's on different sides.
Okay.
But you're going to still end up with the same number. It's just going to be negative.
Let's see what the quiz says. Variable 1 and 2. Okay. All right, yeah, that's what they totally did. Freak.
What's that?
In the information for questions 12 and on, at first it says, this data represents the number of times freshman students from Utah and Colorado cook their own dinner, right? Second paragraph says, you suspect that freshmen from Utah cook for themselves. Oh, wait, where is it? Oh, so in that first paragraph it says, let U1 represent the mean number.
Oh, yeah. Okay, I see what you're talking about. U1 is Colorado and U2 is Utah.
Yeah. So we just gotta switch that. That's all this time because of that.
Yeah, really. Thanks for making statistics difficult.
Yeah.
Like we need help in that, right?
Yeah. You say that changes anything.
All right, so we got the p-value. Yeah, that's why I was like, the t-score should be okay because we have the right p-value. So, I mean, that's the only thing I could think. You know what I mean?
All right, yeah, it's negative. Dang, well, that's one answer. Now we just got to figure out the other one.
Yeah, what's the margin of error for 95% confidence interval?
All right, so these standard deviations are different because now, oh wait, no, it's just switched.
Negative 0.845, right?
Yeah. So for number 16, with the feedback that it's saying the answer in SPSS is slightly lower than Excel. So the answer given is the average between the two results. The result should be close to the answer shown. What's SPSS?
Is that Apple version?
Actually, that's probably what it is. Okay, so, and it says the answer given is the average between the two results. So with that two results be the average between the two margin errors that are on that.
I'm assuming.
Standard error of the mean is 1.428 and then 0.987. Is it the average of those two numbers?
Could be.
Okay. I got 1.208.
On your standard of error or the
Yeah, for the margin of error.
the margin of error?
Yeah.
You know, and I bet you're right. I mean, like I said, I think you have to add them, divide them by 2, and get the middle, right? Since we're doing that to the standard deviation and the mean, so it wouldn't make just sense that you're going to get the standard. You know what I mean?
Yeah, that makes sense.
I don't know. That's you guys are way smarter than I am, so.
I wouldn't say that.
2, 4, 5. 1, 2, 0, 8. What'd you get? 1.208 or 1.21?
I got 1.208.
All right.
And for number 17, I got negative 5.147. And number 18, 2.214. And it shows it on the Excel sheet now.
Oh, because you switched the numbers?
Yeah.
Oh, gotcha. Let me try that.
Josh, are you still on here?
Yeah.
What other questions do you need help with?
Well, I guess just 9.
Number 9.
Or not 9, 14. Is that 0.396?
Number 14 is 0.411. So on your Excel, if you put the confidence level at 0.95,
Yeah.
and the type of test not equal to,
Okay.
you should get the p-value of 0.410728. And you know what your p-value is.
Right. So I just submitted it, and the margin of error is not correct for 16. But all are correct except 16. It's not 1.208.
Shoot, I don't even know how we would get it then.
The way that it makes it seem as a response to the question is it has to be in the vicinity of the answer we provided, around 13 or so. Is that an incorrect assumption? I don't know.
So 1.2, that's wrong.
Yeah.
Yeah, but the feedback for number 17 and 18 are the same thing, so I don't know if it really helps us. You know what I mean?
Yeah.
Oh, yeah, I see. Yeah, I see that.
So, oh man, I don't know how to do the margin there.
I'm good with 1 out.
Me too.
It's called the law of averages, man.
Yep, there we go. All right,
Get the
well,
ones
good job,
you
guys.
do and don't struggle on the rest.
Yeah. Sweet. Well, I'll turn this recording in.
Sweet. Sounds good to me.
All right.
Thanks, guys.
You guys have a good evening.
A lot.
All right. Yeah. Thanks for your help, man. That was tough.
Yeah. Well, thanks to you guys. You guys helped me too.
Eh.
Yeah.
Cool.